Okay, so we've been working with displacement versus time graphs. Next thing we're going to be looking at is velocity versus time graphs, and these have to be read completely differently. For example, we have time along the x-axis just like before, and now we've got velocity on the y-axis. Notice that there's a 0 in the middle, and there's a positive region of the velocity and a negative region of velocity. So if we want to say what car A is doing, looking at car A, the velocity is staying at around 11 or 12 meters per second. So car A is moving at, let's say, 12 meters per second. While it's moving at a constant velocity because the velocity isn't changing. And notice that this car is moving. If this was a displacement versus time graph, the flat line would mean it was stationary, but that's not the case here. So car A is moving forwards at a constant 11 meters per second. What about car B? Car B is moving backwards at a constant, let's say, negative 33 meters per second. So again, you got to read these a little bit differently. Let's look at what this guy is doing. So the velocity starts out at 0 and then gradually increases. So this guy is moving forwards because he's in the positive velocity region, and his speed is increasing because it's moving away from the 0. Okay, it's increasing. So moving forwards and speeding up. So if the velocity is positive, because it literally is positive, now if it's speeding up, that means that the signs in the velocity and acceleration are the same. So that means that the acceleration is also positive. Let's see what this guy is doing. This guy is maintaining a constant 0 meters per second. So this guy here is stationary. So the signs in velocity and acceleration are both 0. It doesn't have a sign. Let's look at this one. So moving forwards, backwards, moving forwards or backwards. Well, if this was a displacement versus time graph, it'd be moving backwards. But it's a velocity versus time graph, and it's in the positive velocity region. So since we're in the positive velocity, we're moving forwards. Now the downward slope here is because we're decreasing in speed. So we're moving forwards and slowing down. This guy, moving forwards or backwards. Well, now we're in the negative velocity region, which means we're moving backwards. And what's happening to our speed? Well, the speed is increasing in negative numbers, so it's getting faster in the negative region. It's also moving away from 0. So it's moving backwards and speeding up. The velocity would be negative, and the acceleration would also be negative because it is speeding up. This guy, moving forwards or backwards. Did I trick you? It's still moving backwards because its velocity is in the negative region. No, it's moving backwards and it's slowing down because the velocity is getting closer to 0. So the velocity is negative and the acceleration in this case would be positive. What about this guy? So this guy is originally, there's three distinct points or locations in this graph. There's this region, there's the time when it crosses the line, and then there's this region. So in this region, it is moving forwards because it's got a positive velocity, and it is slowing down because it's approaching 0. When it reaches this line, it comes to a stop. So it's moving forward, slowing down, coming to a stop. Okay? And then when we cross this line into the negative region, we start moving backwards, and we're speeding up. So that's the motion. So if you were to roll a ball up a hill, that would be an example, or throw something in the air, moving forwards, slowing down, coming to a stop, and then moving back the opposite direction, speeding up. Okay, so what do we got here? So in this region, we are moving forwards at a constant speed. And this is now switching back to a displacement versus time graph. Always make sure you check. So this guy is moving forwards at a constant speed, coming to a stop, and then moving forwards at a constant slower speed. Okay, so we can't forget the displacement versus time graphs. We just got to keep them separate. Okay. Let's see. What do we got going on here? So this is a displacement versus time graph. So we're sloped down, which means that we've got a negative velocity. We're moving backwards. We're moving backwards at a constant speed, constant negative velocity. Same thing. And then right here is when we change our velocity, and we start moving forwards at a constant slower positive velocity. What's this guy here doing? So we kind of have three distinct regions again. We've got this region here, we've got the tippity top, and then we've got where it switches directions and starts coming the other way. So this side is saying it's moving forwards, okay, because it's sloped up, and it's slowing down because it's getting flatter. Okay, so moving forwards and slowing down. Okay. Eventually we reach a point where we come to a complete stop. Okay. And then over here we start sloping downwards, so we're moving backwards and speeding up because we're getting steeper. So speeding up at a negative velocity. Okay, that is it for today. So we're going to do worksheet 2.35, and this is a good one. So it'll help you crystallize some of these ideas in your brain. Feel free to refer back to the notes and stuff, but try to do it on your own. And have a good day.